Good day, guys. Welcome back. I'm going to continue with my series on skills for Newton's second law, and we're going to look today at systems, for us objects in systems, and how do we solve systems. This is something that comes up very often in mechanics, so it's very important that you know how to do this. Okay, so if you follow me, we'll see here that there is two blocks connected with each other with a string or a rope and the applied force accelerating towards the right. Okay, now if you would follow me, you would see that the first important thing is that each block has its own diagram. Okay, in this case we're going to ignore friction. Friction does make it a bit more complicated. I'll add friction at the end. So here we have the applied force. If we look at block A, the applied force is technically only being applied to block A. So block A is also experiencing a force holding him back, and that is the tension. Okay, so that's block A, and this is block B. And block B now is pulled forward by a force called tension. Okay, now obviously both of these blocks do have weight and the normal reaction force, or called the reaction force sometimes. Okay, so these blocks, if you look at the question again, does not move up and down, they move horizontally towards the right. Therefore these forces, the vertical forces, will cancel each other, and the only thing that affects my acceleration is the horizontal forces. Now, the trick with a system is you can either look at it as one big system, or you can look at it individually. So if we look at block A individually, Newton's second law says the resultant force is mass times acceleration. Okay? In this case, the resultant force consists of an applied force minus a tensional force is the mass of A times the acceleration. Now we can do something similar for block B. The resultant force of block B is equal to the mass times the acceleration. In this case, the only force acting on the tension, on the block, is the tension, and we have mass times acceleration. Okay, so this is if we look at each block individually. But we can also go further and combine them into a system. Now, if we put them into a system, we add them together. Okay, so this means that I put block A, that's the mass of A, and then I put B, that's the mass of B. Forgot to put it here. Okay, and now if we add this together, so we're going to just mathematically add the terms on the left and the right. On this side we'll have an applied force. On that side we'll have the mass of A times the acceleration plus the mass of B times the acceleration. We know that the acceleration is the same because these two objects are connected. Block A cannot travel faster or accelerate more than block B, and block B cannot accelerate faster than block A. So the acceleration is the same for both of them. And basically, we have that the acceleration of the system is the combined mass times the acceleration. So this is if we look at block B individually, this is if we look at block A individually, and this is if we look at the system. Okay, now where do I apply this? When I'm asked to calculate these questions, they're usually going to ask you to calculate firstly the tension and secondly the acceleration. Now this is going to cause you to have to use a simultaneous equation, and they love to do this because this is a mathematical subject. Okay, so when I want to get the acceleration, I get the two equations. So I'm going to start off by getting the two equations from the diagrams. If I miss out something on my diagram, I'm going to miss it out on my equation. So very important to always draw your diagrams. So I get my two equations. I add them together mathematically. Alternatively, you can go and make A or T the subject, okay? And you can go and solve first A and then T, or you can add them together in this method. Two methods to solve simultaneous equations. I think there's even more. Okay, so by the way, I didn't just clarify here. Here we've got a negative T and a positive T, and a positive and a negative cancels out, and there we only have the applied force on the left. So what I will do is when I solve my tension and my acceleration, I'll first get this equation. I have my masses, I've been given the applied force, and I get the acceleration. Once I have the acceleration, I take that value and I plug it into one of these two equations. Now be very smart. Look at the simplest equation and choose that one. So I'll plug it in here. I'll use the single mass of B this time, and then I can solve the tension. And that's how you would basically solve a system question. Now the system questions can start looking different. You can have where there's friction. You can have where there's an applied force at an angle, and then you'll have components. Okay, you can have something like this where the forces of two objects do not have a rope in between, but they have a contact force like Newton's three forces between them, action, reaction. So in this case, block A, let's just erase here. Remember, draw the diagram separate. We have a applied force. This block A, block B. The applied force is pushing this way. Now quickly look at the question again. Do you see that the applied force is pointing towards the block? Okay, but I always draw the arrow away from the block just to avoid confusion, makes it simpler. Okay, so block B is being pushed by block A, so that is A on B. But block A is also pushed back by block B, so that's B on A. Okay, now we have a system here. Obviously, if we had friction, we would include that, and the vertical forces there would cancel each other out. So here we would have the resultant force here. We know according to Newton's third law that these two forces are equal but opposite. So they will, if we consider the system, they will cancel out. Now, as I've discussed with you guys, this type of question is very often seen, either this or a pulley or something like this. So it's very important that you would be able to use the system questions or know how to approach this. Remember, we first draw the diagram, then we get the individual equations, then we get the equation for a system by using simultaneous equation, solve acceleration, solve tension. If you can do the steps, you get a lot of marks in mechanics and even in physics. I hope you have an awesome day, and if you have questions, please leave it at the bottom.